Hello, everyone. This is going to be a really exciting seminar because, if nothing else, it's going to dip our toes into daylight design and kind of look at, why are we daylighting buildings? But most importantly, the real importance of the view and how to get access to views for everybody. We're also going to start on some tools for daylighting so that you can actually see on when you're beginning a daylight design, how do you analyze it? So let's begin. As I mentioned, importance of daylight and views and designing with daylight. If you look at daylit spaces, some of them you really like, and others may not be so pleasant. And you start beginning to figure out of what it is about the daylit space. Here's an example of a kind of a cafeteria for a school in Fort Collins, Colorado. And we decided that we wanted the entire area daylit because it was so good for the students during their breaks to be in daylight and view space. Now notice that the electric lighting is off because the daylighting is doing such a good job. And when we're talking about net zero energy buildings, which is especially true in different states, that they've got goals to meet net energy buildings, we start looking at, well, how do we get there? And of course, every line design begins with daylighting. Views to the outside. This is something that is not always considered. And if you look at even how buildings are sited, where they are, and where things are located within the space, views to the outside are extremely important. In fact, there's been a lot of research done on the importance of the view. Lisa Heschong, formerly of Heschong Mahone Group, has done probably the most research on daylight and views. She began her work with schools and noticed that students in schools with views had the highest percentage in test scores. And she looked at over 3,500 students and in schools throughout California. Her latest work was actually on call workers, where she looked at call workers that were in a basement and then call workers that had access to views. And unbelievable difference in how they process calls, what their attention span was, and also of how often did they get up and just stop working and to go take a break. And so some of the statistics are incredibly important. When we start looking at designs and going, oh, we can't afford daylighting, or we can't afford the views, windows are too expensive. If you start looking at these statistics, it really makes a difference. In fact, look at the salaries. I mean, salaries of office workers far exceeds anything else, even in building the building itself, that you can pay back. In fact, Lisa said by providing views for the call workers, you would pay back in increased productivity to the building owner the cost of the building within 1 year. So let's get into the daylight design specifically and where we actually start looking at daylight design in the whole design process. Yes, urban design and site planning are incredibly important on where the site is located, where the orientation of the building is, and just looking at these decisions. Hopefully, daylighting is part of those decisions and also where the view is. The whole solar orientation. that if you can get north and south orientations, those are the most effective orientations to bring daylight into the space. You can go about 15 degrees either way or either direction from north or south for the optimum sun control. But as you start introducing east and west orientations, there's going to be times during the day that you've got direct sun coming in and there's nothing you can do about it. In fact, it's one of those things where I tell all my students that we know the sun's always going to come up in the east and set in the west, or at least close enough. And that's going to be from here for the end of time. So our buildings can start being designed and realizing that this is the way it is. This is a tool that we have used ever since I was in school and doing daylighting design. They're called sun charts. And by the way, you can download sun charts from the University of Oregon, and there's the website for it. You put in your latitude, your longitude, and it will pull up exactly on where everything is. And we start looking at what this sun chart is and how we can look at this data. The blue part of the sun chart actually is organized in hours of the day that are vertical coming down. The around the sun chart is the north, south, east, or west orientations and how many degrees off you are from that. And then, of course, on the very edges of the sun chart, you can see the days of the year. So this is an incredible representation on where you are. And this is not only used for buildings, it's used for solar panel orientation. These sun charts are extremely valuable and kind of fun to at least begin your design. Here's an example of how you can use the sun chart. If you start looking at, if I have got a 30-degree or a 30-inch overhang, you start looking at where the sun is coming in, and you can plot it on the sun chart. If you go to the University of Oregon website, they have exactly the type of incredible instructions in how to use sun charts and how to actually get into these diagrams. I just wanted to show that what the shaded part is saying in the sun chart is where you're not going to get direct sun in. And you can look at the hours of the day, and you can look at the times of the year of when direct sun is not going to penetrate into the space. The darker blue is actually to show that you have got the greatest value of glare control, and then the lighter blue, which is going to be a 45-degree cutoff, you've got less glare control, but it's still extremely important. But let's start adding different types of systems on. What if we start looking at some vertical shading, which is great for east and west orientations? And the green actually shows what the vertical shading will do for this particular design. And then if we made the overhang a little bit longer, like 45 inches instead of only 30 inches wide or long, then you can see that you actually get more shading inside of this space. And one step further, what if we added an internal skylight or an internal light shelf that would actually take the light and bounce it back up into the ceiling? And you can see with this combination of the external and the internal sun shelf that you've got the maximum amount of shading within your space. So like I said, these sun charts are just kind of a great way of starting a design. And before you jump onto the computer, you can kind of go, where am I going to begin? And how am I going to begin with the different elements of sun shading? Once you've done that, you can always go into the computer and do daylight modeling. And there's many, many different programs that do this. And in the daylight modeling, the one that we use Light Stanza a lot, and also AGI 32 are the two modeling programs that we typically use. The nice thing about those two programs that they do have the different applications that you may need for the LEED certification or the well building. This just shows you of how the daylight modeling will really show you throughout the time of the day on where the daylight is in your space, so you can start going, is it okay? Is it, do we need to mitigate it? This particular model is kind of an open atrium for a university, and the architect kind of decided that's great. We need direct sun coming into this space throughout the day. When you go into the daylight programs, you actually can start looking at where you're getting in the daylight, what the percentage of space is of a regularly occupied space, and what kind of levels you've got. This type of programming is called spatial daylight autonomy. And spatial daylight autonomy basically assumes that you have got great daylight coming in, and if direct sun comes in, that the shades will be pulled. It's really an incredible program, and to start looking at how we start pulling together and analyzing the entire space of a building. But along with daylight autonomy is another type of measurement called annual sun exposure, or ASE. And that's basically is saying that no more than 20% of the space has direct sunlight for more than 1,000 lux, which equates to 100 foot candles, for a maximum of 250 days per year. And these metrics are within the LEED standards and also within the well building. Now, here's the difficulty in both of these standards. It looks at mostly the entire building versus just a space that is your space or your office. And that's one thing that we are trying to maybe modify in it and say it may be great to have daylight and direct sun in a corridor or in a lobby area or a break room, just like I showed in that high school. But if you're trying to work on a computer and you have no control coming in, that's an issue. Let's get to designing with daylight on what are the different methods of designing, and how do you begin your design once you understand of where it is. We have got daylight distribution, and there's different ways of looking at daylight distribution. The light shelves that we showed originally on the sun path diagrams. We also have what we call top lighting systems. Yes, they're kind of skylights, but what I would prefer is if you take the sun in and bounce it back up into the ceiling. Every time you can take direct sun and fill the space, fill the ceiling, fill the walls with daylight, that's the best, versus having hot spots on the floor or on your workspace. And if, like I mentioned, on the east and west facing windows, please use vertical shading because it's the most effective. And you can always go back to those sun path diagrams and see what that looks like. There's also terminology that we have where when you want to look out a window, that's called a view window, where the upper windows up above are daylight windows. The daylight windows specifically are designed to get daylight high into the space and as far into the space as possible. The view windows we're going to treat differently because that's where we want people to be looking out, but the view windows also may present the greatest glare potential. We're going to look at these separately, and even, I just love it that way back in history, view windows and daylight windows were even shuttered differently, that this is a concept that has been around since the beginning of architecture. And we definitely have different types of delivery systems. In this particular chart, you can see that the daylight delivery system hitting a light shelf and redirecting the daylight back up into the ceiling. Here's an example on the left, which was the Lewis and Clark office building by B&IM Architects, where they put in the corridors, the transition space next to the windows, mostly because they had more direct sun coming into that area, and they thought people walking around is fine with direct sun. But look at their light shelves, very, very creative, that it doesn't necessarily have to be a hard surface. It could be a surface that is translucent or free form, like this type of fabric light shelf. And as you separate the windows, the way you shade them can also be different. The daylight windows, again, you want a lighter type of shade. And in the view window, different types of shades that you have that are below. When you're looking at side lighting, the one thing, it's the size of the window is incredibly important. There is nothing worse than having small apertures in a wall versus something a little bit larger. The smaller the aperture, the contrast between that brightness and the wall kind of goes into visual overload. So be really careful in doing little punched openings in your design. I would highly recommend against that. Other metrics that you can do, or features, is to actually look at the sill and maybe change the sill shape to make it softer and that it's not a really, really sharp edge. This was a very interesting exercise where in the design, we started looking at the furniture arrangement and where the lectures were. On the picture on the left, imagine that all the students are there looking to the professor up front, which is kind of where your orientation right is. If the sunlight is coming in those windows, all of the students will be in silhouette, and the professor will not be able to see them, be very, very uncomfortable. Where if you put the windows on the side, like on the picture on the right, then everyone gets the joy of the windows, but nobody is in silhouette. Just looking at where furniture, things are related to within this space is really important in this particular design. And then looking at when you want to do top lighting or skylight orientation to make sure that you're shielding it and you don't have direct sun coming down into this space. There's a lot of different fun designs in shielding. And again, you can do this in modeling and to figure out what are you going to do and how do you shield it to get a really enjoyable top lighting system. Here are some methods that you can use. You can bring light in from a distance. And there's some great products out there that actually do this, that have film inside of the tube, basically, that will reflect the light almost to, 99.9%. Some of the films are designed so that they do bring in some of the red light from the sun. A lot of films, for some reason, the red light is absorbed, and so the skylights look super blue when the light coming in. So look for different ways of doing that and kind of experiment. You can also get motorized blinds for some of the skylights when there's a real glare issue that you can almost like dim the daylight with a motorized blind. Here was a project that we worked on where the guard and the receptionist was having incredible daylight issues, glare issues coming in. And we needed to resolve this with an existing system. We could not change the top lighting system, so we thought, how can we reflect the daylight so that it can be useful and kind of enjoyable? And again, sun angles are the same regardless. So we just kind of started sketching of where the winter sun was and the summer sun and autumn sun and going, what can we do? What can we design that will help reflect that? And we looked at different types of lighting or reflector systems into helping to reduce the glare. And you notice that each panel is kind of at a different angle depending on the time of year, the time, the direction of the sun. Yes, then we went into computer mode and actually modeled it to kind of see of where we were at these different times and what the critical one. Here's the final design, and they love it because it's kind of creative. It is a fun feature in the space, and very few people realize that it's all there for a purpose. So I'm encouraging you all to be creative and to be innovative in your designs. This is actually a store in Colorado that wanted to go as close to net zero as possible. And they did two different daylighting systems. One is the skylights, which are to the far left corner and having the light come in. And then we did some clear story windows that would actually bring in the light and bounce off the ceilings. Of course, the result is that they loved the clear story window approach because the ceiling was brighter versus the skylight approach, where the ceiling next to it is extremely dark and too much contrast. So this is an effective way. And again, to make this work, try and get those clear stories to be oriented south as much as possible. Well, now we get into the actual glazing and the shading devices and just some rules of thumb on where you can start here. These are Nancy Clanton's rules of thumb. There's nothing there that is hard and stone, but it's just kind of fun to begin on where we are and what we should be doing. From the height of the windows to, yes, definitely use aperture controls, which are blinds. In fact, I would say have blind options for all of your daylighting windows, especially in view windows, especially if they're in regularly occupied spaces. Visual light transmittance, that's another factor that is used. And notice that the view windows have less light coming in than the daylight windows. And then again, just avoid those punched openings. And then the last issue is going to be solar heat gain coefficient. You can work with the mechanical design and figure out modeling for the entire space of what is appropriate. Remember, look at your design. It could be multiple different light shelves, internal, external, and that's going to be your design that's never going to change. But then you also need some shading. And these shading devices can either be fixed, like I mentioned, or not fixed and changed seasonally, or even use landscape. In the summertime, of course, any kind of deciduous trees are going to be a different element than something that's not. You know, something that loses its leaves versus not. Consider the landscape, consider the orientation, and build that in. And then on the far right, yes, definitely put in shades. If you've got horizontal shades, those are great for the south and the north orientation. Vertical shades are really good if you have east and west orientation. But my favorite, of course, is in the far right corner, far right picture, and that's going to be shades that are bottom up and bottom down. The bottom up and bottom down shades, well, I like them. I've got them in my office, in my home, that sometimes I just want to pull from the top down so I get daylight into the space, but it's at the bottom that I'm getting the glare on my computer screens. Or in some spaces, just for some privacy, if people are walking past and it's bothering you, but you can adjust it depending on where the daylight is. And those, I think, are going to be kind of the new thing, is to all shades will be bottom up and top down. Top lighting systems work. You can have some glare issues if you're not redirecting up, but for interior spaces, it's bringing in basically free light and extremely energy efficient. This was a project we did for Walmart way back, and looking at different types of top lighting systems. The one system, or the top lighting system that looks kind of like a windshield, that was specially designed to get the daylight and redirect it to the back of the windshield. The manufacturer that made these stopped making them after this, but boy, if any of you are creative and innovative, this would be an amazing system that you could sell, and you could orient that top lighting system to reach everything. We looked at that in comparison to just normal skylights, which are in the upper right, and it was a very important difference between the amount of glare that came into the space. But basically, you don't need a lot of top lighting systems, but you can use that and absolutely model what the results are going to be. Light pipes, like I mentioned before, can bring light all the way down into the space. There are manufacturers, like I mentioned. There's one really good one in California. I'm not going to mention the name of them, but I would think if you just go on the web and start looking at systems and photometric data to start using it. And here is just some information, again, complete Nancy Clanton's start on everything, on what you want for your uniformity ratio for your daylighting. You want things uniform, and you want things so that you don't get hot spots inside the space when you don't have any type of blind system. Also, just looking at what kind of foot candles, and you know, to start off with, look at the equinox. Look at March 21st, just kind of a noon sunny day, and where are you with your design? Then, how much of your wall space should be side windows, or how much should be for top lighting if you want that? 40% for side windows and 5% for cloudy, mostly cloudy days, and 3% for sunny days. Once again, this is only a starting point. If we look at the interior forms and surfaces, this sometimes has more of an effect than almost anything else in your design. Making sure that your paints are very light, that you want to reflect things, and where can you share lights? like looking at using interior windows, especially for rooms that don't have access to daylight easily. Once again, here are some starting points for reflectances within your area. One of the toughest things is when you've got really dark walls and dark furnishings. Try and lighten things up if at all possible. And then just where your space is and your whole furnishing arrangement. I just keep thinking that this is really fun to do, because this is what you don't want to have happen, is that somebody has glare coming in and they cannot do much with it. I love this picture because the guy wants the view. He's looking at mountains. He's looking at activity going out. But then that sun's coming in and he can't see a thing. Where you put furnishings, where you use the space can be highly considered when doing daylighting design. Working with the interior designer, or the as we call FF&E, furniture and equipment, you look at this and go, okay, let's work together. In fact, in my office, everybody has desks that they can move around, and they do. They all move it around and go, no, I want to be in this spot today or that spot today. And they move from space to space. I feel that this is going to be the future, that we're no longer in fixed areas. So with that, I just want to, you're welcome to ask me any questions, to email me with suggestions or anything you did not understand with this seminar. Thank you so much.